Section 1.1 Angles. Basic terminology. A line means a straight line, not a curved line. A line that passes through points A and B is denoted by the line AB. You could see we do have two arrows with the straight line to represent the line AB. A line segment has two endpoints, has finite length. We use the notation line segment AB or line segment BA to represent the line segment with endpoints A and B. So you can see for the line segment, they cut out of two arrows. And the line segment AB, that will be equal to the line segment BA. A ray has a starting point and extends indefinitely from the point. A ray that starts at A and passes through B is denoted ray AB. For the ray AB, we only have one direction. And keep in mind that the ray AB is not equal to the ray BA. An angle consists of two rays in a plane with a common endpoint. You could see I do have two rays in here, and these two rays are the size of the angle. The common endpoint is called the vertex of the angle. So this is going to be the vertex A. And it forms an angle in here. An angle's measure is generated by a rotation about the vertex. The ray in its initial position is called the initial side of the angle. If the angle starting from this side, we call this as initial side. And if my angle start at this side here, we're gonna call this is the terminal side of the angle. And you can see for the angle, they're going counterclockwise. Positive angle. The rotation of the terminal side of an angle is counterclockwise. So the angle starts at this side. So this is my initial side. And then we're going to stop at this side. So this is my terminal side. And you could see the direction of the angle is counterclockwise. So this is the positive angle. And look at this example. We start at this side, so this is the initial side, and we end at here. We end at the ray CB. So that would be the terminal side. And since we are going the clockwise direction, so this is a negative angle. The most common unit for measuring angles is the degree. A complete rotation of a ray gives an angle whose measure is 360 degrees. So you can see when I go for one circle here, this is 360 degrees. Angles are classified by their measures. If your angle is in between 0 to 90 degrees, we call this as acute angle. If your angle equal to 90 degrees, and you could see this is notation of the 90 degree, we call this as a right angle. And if your theta is in between 90 to 180, we call this is going to be the obtuse angle. And if the angle is a straight angle, is on a straight line here, then theta will be equal to 180 degrees. Supplementary angles are any two angles with measures that add to 180 degrees. If I have two angles, just like this two angles, 130 and 50, when they added up, that's equal to 180 degrees. We could say these two angles are supplementary angles. Complementary angles are any two angles with measure that add to 90 degrees. So you could see 40 plus 50 degrees, they will be equal to 90 degrees, and we call this is going to be complementary angles. Let's try to do the example 1. Finding the complement and the supplement of an angle. For an angle measuring 40 degrees, find the measure of its complement and its supplement. Okay, for the part A, if I want to find the complement means when two angles added up, that will be equal to 90 degrees. So now I do have one of the angle, that's a 40 degree. We're gonna subtract the measure of the angle from 90 degrees. Okay, complement of 40, that will be equal to 50. Okay, now I want you guys try to do the B. Find the supplement of 40 degree. Okay, in order to find the supplement, we're gonna subtract the measure of the angle from 180 degree. Okay, 180 degree. So 180 minus 40, you should get 140. Example 2, find the measure of each marked angle. So you could see we do have the white angle here. White angle means 90 degree. So sum of these two angles will be equal to 90 degree. We're going to combine the 9 terms and then divide it by 9 for both sides. So we found out x equal to 10, but we are not done yet. We have to plug in back to here to find out what is the complementary angles. So you should get 60 and 30 degree. Okay, example 3. Same idea. You could see these two angles are on the straight line. So added up, that will be equal to 180. Okay, supplementary angles. Do the same thing, combine the 9 terms. And then divide it by 10 for both sides. After you figure out the x, plug in back. Okay, 4 times 18 equal to 72. And 6 times 18, that's equal to 108 degree. Degrees, minutes, and seconds. So in a full circle, we do have a 360 degree. And 1 degree is represent a really small angle. And for this 1 degree, we could also break it down into 60 smaller units. And we call this as the minute. And for 1 minute, we also can break it down into 60 smaller units. And this is called the seconds. So let's look at this example. We do have a 51 degrees, 22 minutes, and 48 seconds. So we could write on 51 degree, 22, we use the single take to represent the minutes, and the double take will represent the seconds. So this is called 51 degree, 22 minutes, and 48 seconds. And here's a look at the relationship between these fractional portions of a degree. So 1 degree equal to 60 minutes. So we could write it like 1 degree equal to 60 minutes. Also, another way to say is going to be 1 minute equal to 1 over 60 degree. So same idea, 1 minute equal to 60 seconds. So you could write it like 1 second equal to 1 over 60 minutes, or 1 seconds equal to 1 over 3,600 degree. Okay, so this is gonna be the conversion. You could convert degree to minute, minute to second, or another way around. Example, I want you guys try to perform each calculations. Okay, let's try to do it together. We'll be using the vertical format, okay? And then you're gonna add the degree and minutes separately. So first, let's try to add 29 minutes and 46 minutes together. So 9 plus 6, that'll be 15, right? So add 1 from here. So 2 plus 1 plus 4, which is gonna be 75 minutes. And then this one, that will be 83 degree. We are not done yet because we know 1 degree, that is equal to 60 minutes. So we do have a 75 minutes here. Can I write it like this? I break it down, degree and minutes. And 75 minutes, I can write 60 minutes past 15 minutes. Okay, right? Add it up, that's equal to 75. And then you know 1 degree, that is equivalent to 60 minutes. So this guy become 1 degree. And then we're gonna add up the degree together. So 84 degree, 15 minutes. Okay, B. This time we want to do the subtraction, but I do have the 90 degree. I don't have any minutes here. So first, I'm gonna convert 90 degree to 89 degree. I'm gonna get 1 degree into 60 minutes here. Okay, they are equal to each other. 60 minutes, which is gonna be equal to 1 degree, and add it up, that'll be 90 degree. Now, I'm gonna use the vertical format to do the subtraction. So 60 minus 12, which is 48. And that will be 16 degree. So this is gonna be your final answer. Okay, example 5. Convert 74 degree, 8 minutes 40 seconds to decimal degree to the nearest thousands. So I'm gonna break it down, 74 degree, this is good. And then I do have 8 minutes. Okay, 8 minutes. So I want to convert it to the degree. So I will do 8 minutes divided by 60. And then 14 seconds, I want to convert it to degree. So 14 seconds divided by 3,600. Okay, 8 minutes divided by 60, that will become the degree. 14 divided by 3,600, that will be the degree also. Try to get one more decimal space to the thousands. Okay, so we could round it up. Add it up together. Okay, another one. I want you guys try to do it by yourself. This time I want to convert it to the degree, minutes, and second. Okay, you could see I do have 34.817 degree. So first, separate with the decimal space in here. And then I'm gonna multiply 60 minutes to this degree. You should get this guy. And then the 49, that will be the minute. So I still have the second. So I'm gonna multiply 60 for this guy again. Okay, you should get this one. And then I have the 1.2 seconds and I try to round it to the nearest seconds. So it's gotta be 0.1. Okay, standard position. An angle is in standard position if its vertex is at the origin. Okay, the vertex, the corner here, is going to be the origin. And its initial side lies along the positive x-axis. Positive x-axis means here. Okay, we call this as the standard position. And the angle will be going to counterclockwise, so this is going to be positive angle. And if your terminal size is lying on here, we call this is going to be quadrant 1 and quadrant 2, just like here. Terminal size here, so quadrant 2. And if your terminal size in here, that will be quadrant 3 and quadrant 4. Okay, 1, 2, 3, 4. Quadrantal angles. Angles in standard position whose terminal sides lies along the x-axis or y-axis, such as the angles with the measure 90 degree, 180, 270, and so on, are called quadrilateral angles. So look at this picture. Lying on x-axis or y-axis. So this is a 0 degree, 90 degree, 180, 270, or 360. If your terminal side is going to be lying on this 90, 180, 270, or 360, and we're going to call this as quadrilateral angles. Coterminal angles. A complete rotation of a wave results in an angle measured 360 degrees. By continuing the rotation, angles of measure larger than 360 can be produced. Such angles are called coterminal angles. We could look at this example. I do have the first angle. This is my initial side. Go counterclockwise, hitting the terminal sides. And this is 60 degrees, right? Okay, look at the red line. I do have the same initial side. And then I go for one circle, 360. And then I'm going to add 60 again. That will be 420. Okay, and we call 60 and 420 will be the coterminal angles. Or you could think about like this definition. Coterminal angles are angles that share the same terminal side and initial side, but have different values. Just like this example, they do share the initial side and the terminal side. Same idea with this guy, okay? Share with the initial side and the terminal side. They do have a different values. So 110 and 830, they are coterminal angles. In order to find the coterminal angles, you could just plus minus 360. You could try 60 plus 360, that would be 420. You could keep adding 360. So that's also the coterminal angles. This one, like 110, you're gonna add 360 and then add 360. That will be 830. If you are working on the radians, then you're gonna do theta plus minus 2 pi. Okay, this is how you guys find the coterminals angle. Example 6. Finding measures of coterminal angles. Find the angle of least positive measure coterminal with an angle of 908. The least positive angles. So we're going to subtract, right? We're going to try to subtract 360. So you're going to get 548. This is also the coterminal angle, but they want to find the least positive. So we're going to try subtract another 360. Okay, 2 times 360, subtract from the 908. You're going to get 188. So this is also the coterminal angle. If we keep subtracting 360 again, I'm going to get the negative measure coterminal angles. Okay, so this is going to be your final answer. Okay, B. Find the angle of least positive measure coterminal with an angle of negative 75 degrees. So this time, if I subtract 360, I still get the negative, right? I want the least positive measure. So you're going to use the theta plus 360. That will be 285. So negative 75 and 285, they are the coterminal angles. Okay, another one. I want you guys try to do it by yourself. Find the angle of least positive measure coterminal angle with negative 800 degrees. Okay, so you're gonna add 360 degree. Okay, but you need to get positive. So I'm gonna do 360 times 3. You're gonna get 1080, and then add up with the negative 800. So you should get 280 degree. Coterminal angles. To find an expression that will generate all angles coterminal with a given angle, add integer multiples of 360 to the given angle. So for example, if I want to find the angles coterminal with 60 degree, then we do have this general formula, 60 degree, the theta, plus n times 360. Okay, so I have the table like this. When n equal to 2, I plug it in, I'm gonna get 780. When n equal to 1, that will be 420. When n equal to 0, that will be 60 degree, so it's gonna be the angle of itself. When n equal to negative 1, then we're gonna get the negative coterminal angles. You could keep going on it. When n equal to negative 2, you're gonna get 660 degree. Example, a constant angular velocity disk drive spins a disk at a constant speed. Suppose a disk makes 480 revolutions per minute. Through how many degrees will a point on the edge of a disk move in 2 seconds? So the disk makes like 480 revolutions in 1 minute. So that means 1 minute the disk gonna roll 480 times. But then we want to calculate it in second. So think about it. 1 minute, the disk makes like 480 revolution. How about 1 second? How many times of the revolution of the disk makes? So 1 minute equal to 60 seconds, right? So we're gonna do 480 revolution divided by 60. Okay, we're gonna change from minute to the seconds. And we find out that will be 8 times per second. And then now, how many degrees will a point on the edge of the disk move in 2 seconds? So 1 second, they do have 8 times revolutions. How about 2 seconds? We're gonna times 2, right? And then we want to know the degree. So each revolution is gonna be 360 degree. So we're gonna do 16 times 360. So we find out that will be 5,760 degree in 2 seconds. That's it, session 1.1.